Hello everyone and welcome back to my channel. First of all, I want to wish you a Merry Christmas and a Happy New Year in advance. I hope this season brings you joy and happiness. So in today's video, I'll be showing you how to perform linear regression and multiple linear regression in SPSS. We will cover the concepts, assumptions, and a step-by-step guide to analyzing your data. If you are new to regression analysis or SPSS, don't worry, I will make it as simple as possible. Before we dive in, please remember to subscribe to my channel, give this video a thumbs up, hit the notification bell, and feel free to drop your comments or questions in the comment section below. Your support helps me create more useful and helpful content like this. Now, before I continue, there are other videos on regression, on how to perform regression analysis in R from my previous video. So if you have not watched that and your concern is how to do this in R, you can go back and watch those videos. So what is regression analysis? Let's start by understanding what regression analysis is. First, linear regression. So linear regression is a statistical method used to model the relationship between a single independent variable called the predictor and a dependent variable called outcome. For instance, let's say we are predicting a student's math score based on how many hours they study. So for multiple linear regression, multiple linear regression is an extension of the linear regression that involves two or more dependent variables. So for the simple linear, we are just having one independent. But for the multiple linear, we are having two or more independent variables predicting a dependent variable. For example, predicting math scores based on both study hours and class attendance. So why use regression analysis? Regression analysis is used when you want to predict outcomes based on independent variables, also assess relationships between variables, and finally to determine the importance of predictors in explaining your outcome variables. So what are the assumptions of regression? Before performing regression, it is important to ensure the data meets these following assumptions. These assumptions I'm going to be calling now. So one of them is the linear relationship. So the dependent and independent variables must have linear relationship. Also, no multi-collinearity. For multiple regression, independent variables should not be strongly correlated with each other. The third one is homoscedasticity. The variance of the residuals should be constant across all levels of independent variable. The fourth one, normality of residuals. So the residue should follow a normal distribution. Fifth, independence. So the observations also should be independent. So when do we use a linear or a multiple regression? So we use a linear regression when we have one independent variable to a dependent variable. Then we also use a multiple regression when we are having two or more independent variables to one dependent variable. So now quickly let us go to SPSS. I am having a data here already of math score, which is our dependent variable, to hours of studies and class attendance. So the first thing we are going to do first is for a simple linear regression, and I'll be using math scores to hours of studies. So if you can do math scores and class attendance on your own, part of trying to understand the tutorial, but for the purpose of this tutorial, I'll be focusing on math score and hours of studies for simple linear regression. After which, we would now do for multiple linear regression, math score, hours of studies, and class attendance. So let's dive right into it. So for performing a simple linear regression, we are going to go to Analyze. Under Regression, we'll go to Linear. Now, the math score, which is our dependent variable, we go into the dependent variable box, and hours of study will go into our independent variable box. Now, like I said, we are going to be focusing on math score and hours of studies. you can do for math score and class attendance, and follow the step-by-step process to also interpret your data. Let's go to statistics. You check this box if it is not already checked in your SPSS. Mine is checked already, so I would include descriptive to also get the descriptive statistics, and click OK. And after that, we're good to go, so click OK. So this is our results. So from our results, under the descriptive statistics, we can see that the mean for hours of studies is 4.9026, and therefore math score is 92.4478. You can also see their standard deviation. Now let's go to the next table. The next table here is our correlation table, and from the Pearson correlation, you would see that the Pearson correlation between hours of studies and the math score here is 0.713. So there is a strong positive linear relationship between hours of studies and math score. Now let's go to their p-value. The p-value for hours of studies and math score here is 0.000. All right, so this is telling us that the correlation is statistically significant. All right, so now if you go down, you'll see the number of observations. We're having 1,000 observations. All right, so now let's go to the next model, which is model summary. From the model summary, you will see that R here is 0.713. All right, so this represents the correlation coefficient. R represents the correlation coefficient and indicates a strong linear relationship between the predictor, which is hours of study, and the outcome, which is math score. The R square here is 0.508. Now, this 0.508 here is approximately 50.8%. So what this means is that approximately 50.8% of the variance in math score is explained by the hours of studies. So for the adjusted R square, we are also having 0.508. This adjusts R square for the number of predictors and sample size. That is what this does. For the standard error of estimate, we're having 8.78875. Right, so this is the average distance between the observed, and the predicted values of math score. So now let's go to the ANOVA table. From the ANOVA table here, we can see that the p-value here is less than 0.05. So since the p-value is less than 0.05, this means that the relationship between hours of studies and math score is statistically significant. So let's go to the last table here, the coefficient table. For the coefficient table here, you would see that the constant here, also called the intercept, is 77.464. This implies that when hours of study is equals to 0, the predicted math score is 77.464. For hours of study, we're having a coefficient of B here as 3.056. This implies for each additional hour studied, math score increases by 3.056 on average. Now let us go to the significance here. You see that all of them here are less than 0.05. So therefore, the coefficient is statistically significant. All right, so now let us look at the beta here, standardized coefficient for beta. This indicates that you see that we are still having a 0.713 here, indicating that hours of studies has a strong effect on maths score. So we can conclude here, first, from the model fit. The model fits the data well, as indicated by a strong R square and significant F test. So what are the effects? For hours of studies, we can say that hours of studies has a significant positive impact on math score. Students who studies more hours tend to score higher in maths. Of course, this can be observed from our day-to-day activity. So that is for simple linear regression. The next we're going to be looking at is multiple linear regression. So for multiple linear regression, we are going to be focusing on math score, our dependent variable, hours of studies, and class attendance are independent variable. So let's go to analyze. We go to regression, linear. The math score will go under the dependent box. Then for hours of studies and class attendance would go under the dependent variable. Under statistics, let us check our descriptive box and we'll click OK. So under our descriptive statistics, you can see the mean for both math score, hours of studies, class attendance. So let's quickly go to the correlation analysis. So for the correlation analysis, math score and study hours, we are having 0.713, indicating a strong positive relationship. That is to say, as students study more hours, their math score tend to also increase. All right, so if we look at their p-value here, you would see that the p-value is statistically significant. Okay, so now let's go to math score and class attendance. So for math score and class attendance, you will see that their Pearson correlation is 0.603, suggesting a moderately positive relationship. So higher class attendance is associated with math score. So that is what the result is telling us. So if you look at the p-value here, the p-value here is 0.00000, which is also significant. So now let's go to the regression analysis. So for our R here, you see that our R here is 0.921. This indicates a very strong correlation between the independent variables, the hours of studies and class attendance, to the dependent variable, math score. Our R square is 0.848, which is approximately 84.8%. This implies that 84.8% of the variation in math score can be explained by hours of studies and class attendance. For the adjusted R square, we're having 0.847. This implies that the adjusted value confirms the model's robustness, accounting for number of predictors. So now let's move to the ANOVA table. For the ANOVA table, we are having a p-value here of 0.000, which is less than 0.05, confirming that the overall regression model is statistically significant and the predictors reliably predict maths scores. So that is for this table. So now let's go to the coefficient table. For the coefficient table, the intercept is 40.170, meaning that if the predictors that is both hours of studies and class attendance are 0, the predicted math score would be 40.170. All right, so now let's go to hours of studies. For the hours of studies, we are having here as 2.983, which means that for every additional hour of study, math scores increase by approximately 2.983 points, holding attendance constant. Now, if we also go to the standardized coefficient here, we are also going to be seeing the B for hours of studies, beta for hours of studies, as 0.696. So, which is telling us that hours of study is the strongest predictor, contributing more to the model than class attendance, because this is 0.696, and for class attendance we're having 0.583. Also, when we look at their p-values, you see that their p-values all are less than 0.05, which indicates that the effect is statistically significant. If we go to class attendance, you would see that for B here under the unstandardized coefficient, we're having the class attendance here as 0.500, which means that for every 1% increase in class attendance, math score increased by 0.5000 points, holding study hours constant. For the standardized coefficient, you see that the beta here is 0.583. So it is telling us that the class attendance has a slightly smaller impact than hours of studies. And also you can also see that the p-value here is significant. So for the summary of our findings, we can say that 1. Both hours of studies and class attendance are significant predictors of math score, with hours of studies having a stronger impact. Also, we can say that the model explains a large proportion, which is 84.8% of the variance in math score, indicating high predictive power. So finally, we can say encouraging students to increase study hour and maintain higher class attendance is likely to improve math score significantly. Alright, so these are the results and their interpretation. And that'll be all for today. If you have a question, you can feel free to drop your question in the comment section, and I'll do well to reply. Thank you very much.